Hello friends, welcome back to Sringeri College YouTube channel, and today we are going to discuss Laplace transform of discontinuous function. In previous video we have seen examples on a continuous function or single valued function, and in this lecture we have to discuss discontinuous function or multi-valued function or piecewise functions. So continuous functions or single valued function we can solve by a definition of Laplace transform, as we know that definition of Laplace transform is nothing but f of t, L of f of t is equal to integration 0 to infinity e to the power st and f of t dt. So with the help of this condition we have seen so many signals of Laplace transform, and for example Laplace transform of any constant value we can solve in a frequency domain A over S. For example, suppose we have to find out the Laplace transform of any constant number, that is 2, we can write, just apply this formula 2 over S. So continuous functions only has given only single functions, so we can solve with the help of definition or by using standard formula of Laplace transforms. In discontinuous function we have to solve with the help of the definition of the Laplace transform. So as we know the limit value is any functions, the f of t lies between 0 to infinity, so limit value, and here so in discontinuous functions limit values will be split up or piecewise. I will take, we talk generally here, suppose f of t is in a piecewise function or multi-valued functions, I will take, it means f of t is composed in a different subintervals. f1 of t, it may be f1 t lies between a and 0, and I will take another f2 of t, and that is lies between, the t value lies between a and b, and f3 is lies between greater than b. So this is the discontinuous function, and this one can solve only with the help of the definition of Laplace transform. So please remember, so we can't use the standard formula in discontinuous function, and this one discontinuous function only can solve with the help of the definition of Laplace transform. And we go through the particular examples and we can understand. Find the Laplace transform. Find the Laplace transform of f of t, where f of t is equal to t, and t is lies between 0 and 4, and f of t is equal to 5 and t is greater than 4. So this is the example, and f of t is piecewise function or multi-valued function. So t is lies between, when f of t is equal to t and t is lies between 0 and 4 limit values, and f of t is equal to 5 and then t is greater than 4. So with the help of the definition only we can solve without using some standard signals of Laplace transform. Solution: by using definition of Laplace transform. Laplace transform of, we know that, so 0 to infinity minus st f of t and dt. So this is the definition, and just we have to split up the limit values. When 0 to infinity is the Laplace transform f of t, so but this function is limit values changes. So we can write Laplace transform of given function in a different subintervals with the help of the property of integration. So first I can write, so f of t is equal to t, it means f of t lies between 0 to 4. First value of f of t, limit values is 0 to e to the power st f of t dt, and another f of t value is 5, and above the 4 value, it means 4 to up to infinity, plus, and limit value is another function f of t is equal to, when f of t is 5, then limit values are 4 to infinity e to the power st f of t and dt. Now substitute the f of t values in a above condition. When limit value is 0 to 4, then f of t is nothing but t and dt. When limit value is 4 to infinity, then f of t is equal to 5. So 4 to infinity e to the power st, and f of t value is 5 and dt. Now look at this one, here e to the power st and t are in the product form, and we have to apply the by parts method. So as we know that when variables in product, we have to use double integration formula or by parts method. So here we have to use Islet rule. By using or Islet, we are already familiar with Islet. I is nothing but inverse trigonometric functions like tan inverse, sin inverse, cos inverse, and L is nothing but logarithmic function, and A is nothing but algebraic functions like x square, x 5, x to the 5, and T is nothing but trigonometric functions sin x, cos x, like that one, and exponential. Here T is algebraic function, so I will take, this is the first one, and e to the power st is exponential function, so I will consider as a term 2. And also we know that the integration in a product form with respect to t, so first term and this is the second term, first term keep as it is, and integration of v minus integration of integration v and differentiation of first function, that is u prime. So apply this condition and definitely we will get the solution of above condition. So I will rewrite once again, integration 0 to 4, first I will take t, first term t into e to the power minus st and dt, and plus integration and limit values are 0 to 4 to infinity and e to the power st and 5 to dt. So this is first term and this is second term, and apply the by parts method, and we get first term is t and second term is e to the power st, and apply the by parts method. So here first term keep as it is, t is the first term, keep as it is u, that is u or v. So t is our u and v is e to the power st. So integration of e to the power minus st and dt, we are integrating with respect to t, and minus integration of integration, here e to the power st and limit and u prime is nothing but differentiation of first term, that is 1 and dt. So here phi is a constant, take outside, phi integration 0 to infinity and e to the power st and dt, and here limit values are 0 to 4, 0 to 4, 0 to 4. So in next step, we solve. So t as it is, and integration of e to the power minus st, we know that the basic formula, just apply the integration formula. When e to the power minus st is there, e to the power minus st over minus s, and limit values are 0 to 4, and integration 0 to 4, and apply here integration. So e to the power minus st minus s, and differentiation one is dt, and plus 5u integration 0 to 4 e to the power st and dt. So again here t as it is, e to the power minus st minus s, limit values are 0 to 4, and again apply the integration 0 to for the e to the power st. So e to the power st is nothing but e to the power st or minus of minus plus s into s square, and limit values are 0 to 4, and here 5 into, again apply the here integration e to the power minus st minus s 0 to 4, or 0 to 4, 0 to infinity, 0 to infinity. And now apply the upper and lower limit values. Your upper value is 4, t is a 4, and e to the power minus 4s over minus s, and minus of lower limit when t is equal to 0, and this one is 0. And similarly we have to apply the upper and lower limit minus, and upper limit value is minus t as 4 and 0 minus s 4s a square, and apply here lower limit. So e to the power 0 over a square, and again here 5u upper limit values. When you apply the t is equal to infinity, then it will be 0, when 0 minus of minus, and when t is 0 e to the power 0 minus. So simplify it, 4 times e to the power 4s divided by minus s, and minus of here e to the power minus 4s divided by s square, and e to the power 0 value is 1, so minus square, and minus of plus, minus of minus plus, and it means 5 divided by s. So again we can simplify, take e to the power minus 4 is common, and we get 1 over s e to the power minus 4s, and plus 1 over a square e to the power minus 4s minus plus 1. So this is the final answer of given discontinuous function f of t is equal to t and f of is equal to 5, and this is the final solution of given discontinuous function. And we will see another example with the help of the definition only. So another example is, find the Laplace transform of f of t if f of t is equal to sin t when t value lies between 0 and pi, and f of t is equal to 0 and t is greater than pi. So again, by definition of Laplace transform, we have to solve discontinuous function. So as we know that the definition of Laplace transform, that is f of t is equal to integration 0 to infinity e to the power minus st f of t and dt. So limit value is f of t limit value is 0 to infinity, but given f of t is split up in a piecewise, or f of t is composite in a different subintervals. So f of t is equal to sin 2t and t value is 0 to pi, and f of t is equal to 0, t is greater than pi value. So we have to apply the integration property 0 to limit value 0 to pi e to the power st f of t and dt, and plus when limit f of t is equal to 0, and that is pi to infinity e to the power st f of t and dt. Now f of t value is sin 2t when limit values are 0 to infinity. When limit values are pi to infinity, then f of t value is 0. So here I write 0 to pi e to the power minus st, f of t value is sin of 2t and dt, and here limit values are pi to infinity e to the power f of t value is 0. So when f of t is 0, then whole thing is 0, so no need to be solved again, just we have to solve this condition. Let's now look at here e to the power st and sin 2t and dt. So again here this is also variable and this is also variable, both are in product form, and we have to use the by parts method. If you apply the by parts method to this condition, and it is lengthy process, so we have already derived this one when e to the power at and sin of bt. So that is we know that e to the integration of e to the power at and sin bt and dt. So this is the standard formula, that is e to the power at a square plus b square, and now so a of sin of bt minus b of cos of bt. So apply this formula for above condition and definitely we get the solution. So in next step, Laplace transform of given function f of t, apply this condition. Here look at here, e to the power at is there, a is minus s and b is 2. So where a is there, we just substitute minus s and b is there 2. So e to the power minus st and a square is the coefficient of t is nothing but minus is there, minus a square, and b value is 2. So 2 is nothing but 2 square is nothing but 4, and again here a is minus s and sin of 2t minus, and b value is 2 time cos of 2t, and limit values are 0 to infinity. Now apply upper limit and lower limit value for above condition. So here I will take 1, so I will take minus common, here also minus, take minus 1, minus a square is a square plus 4, and e to the power minus st I will take inside, so So e to the power minus, because t is a variable, we have to apply the limit value. So I taken inside of the bracket minus e to the power minus st, and here s sine of 2t and plus 2 times cos of 2t. So t is equal to 0 and infinite. So minus 1 a square plus 4, and now look at here. First we have to apply the upper limit when t value is equal to pi. So here we have to apply e to the power, upper limit value is minus pi minus s pi and s and sine of 2 pi plus here 2 times cos of 2 pi, t is pi. So next minus, now apply the lower limit value when t is equal to 0. So here e to the power minus 0, when t is equal to 0, whole thing 0, it means e to the power 0, and yes sine of 0 minus plus 2 times cos of 0. So upper limit and lower limit value, and now substitute the values. Here look at here, sine 2 of 2 pi and cos 2 pi. Here sine 0 is equal to 0, or when sine of 2 pi is also 0, and cos of 0 is equal to 1, or cos of 2 pi value is 1. So apply this one, and now minus 1 over a square plus 4. So here sine 2 pi is there 0, and here value is cos 2 pi is value is 1. If you simplify, e to the power minus s pi into this one is 0 and into 2, and similarly e to the power 0 value is 1, e to the power value is 1, sin 0 value is 0, and cos 0 value is 1. So minus of minus, here minus into 1 into 2. So again if you simplify, so I will take 2 common, or minus 2 take common, so 2 over a square plus 4, then 1 minus e to the power minus s pi, and this is the solution of given function f of t is sin 2t and f of t is equal to 0. So this is the solution of discontinuous function, and in next video we will see some examples of discontinuous function. Thank you.